Hi, my name is Derek, and I am from Ferrar's Calc AP 3rd period. Today I will be presenting 2012 FRQ5. So, at the beginning of the question it says, the rate at which the baby bird gains weight is proportional to the difference. This will be a hint between its adult and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it is first weighed, then dB over dt is equal to 1 over 500 minus b. Let y equals b of t be the solution to the differential equation above, with the initial condition b of 0 equals 20. So what this dB over dt represents is the rate at which it gains weight per day. So we will be using this in part A as seen. So for A, since we're finding which one is gaining weight faster, we'll plug in B as the given 40 or 70 into the dB dt equation. So first you would say this when B equals 40. So now you plug it into the equation. So 1/5 100 minus b, and if you plug it in, b as 40, you'd have 60 in the inside, and 60 over 5 equals 12 grams per day. So now we will check dB of dt when you're plugging in the weight of 70 grams. So same thing, you have 1/5 100 minus 70. So that will be equal to 30 over 5 is 6 grams per day. So obviously this one is bigger, twice as big. So the rate of weight gained is faster in the 40 gram bird. So you would say because dB dt is greater than dB dt of 70, and this will be the 41. The bird weighing 40 grams will obviously gain more weight faster. So in the guide, you would get points for dB dt just saying using the rate dB dt and plugging in these values. And this will be the second point for explanation. So now we will move on to the next question. B. Find the second derivative in terms of B. Use the second derivative to explain why this graph is not the same as the graph of the real B. So in B, to find the second derivative, you would have the dB dt here, and you take this derivative first. So the dB derivative is 1/5, or the dB dt derivative is 100 minus b, and if you plug in, or if you distribute these numbers, it would be 20 minus 1/5 b, and since this is a constant, you would remove it, it would become 0, and then this is a variable, it would become negative 1/5. So that would be your kind of u prime, And then taking just the derivative of dB dt, this is just the dB dt portion of the problem. So 1/5 100 minus b. So this would be like the u, and then the u prime on the outside when you're taking the derivative right here. So then now, after getting that, you have the negative 1/25 100 minus b. So to understand how to use this second derivative to prove that this graph can't work, we use it to find where it concave up and concave down. So in this equation, you would find out that anything over 100, it will always be concave up when it's b. So in this graph, it should never be concave up. However, as you can see here, it's concave up right here at this first mark. And then at b between 100 and 20, it should be concave down. And obviously in this graph, it's concave up, then concave down. So this is a change. This graph should only be concave down during the interval 20 to 100. So that's why this graph doesn't work. So you'd have to say, because in graph B, in interval 20 to 100, it should, the d squared b over dt squared is negative, meaning concave down. And then, so this, and then now you just say contradict, but in graph concave down, or concave up. And that's your explanation. So this is where you get a point for explanation. And then finding the double derivative here using this u prime u method. And now we'll use C. Using separation of variables, find y equals b of t, the particular solution to the differential equation with the initial condition b of 0 equals 20. So what you would do, it provided the bird gains weight proportional. So you know the end product. It would be something around a e to the kt. Meaning there's a constant here and it's to the e power because it's proportional to the difference, and this is time. So we're finding that. So for C, you can see the dB dt is equal to 1/5 100 minus p. So this is already like easy separation. You would have dt to go here with the 1/5, so you would have 1/5 dt. And then since this is here, 100 minus b corresponding to dB, it would have the inverse of it. So it would be 100 minus b dB. So now you just take the integral of each, and then this would become 1/5 t plus c, because the constant, this would also have a constant, but it's subtracted onto here. This would be the negative ln absolute value of 100 minus b, because this 100 minus b part right here, it will turn into minus b, so then that's the u prime over u method, and then that'd be u prime would be negative b, so it'd be negative on the outside of the ln. So from here, you just have negative 1/5, right? Negative 1/5 t plus c. It doesn't matter, the sign won't change it because it could be plus a negative number for c. And then now it's equal to ln 100 minus b. However, you can see as the initial condition set b of 0 equals 20, it's going to be positive, so it wouldn't matter. So 100 minus b, because you're taking, to cancel each side, it'd be e to the e. 100 minus b is equal to e to the negative 1/5 t plus c. So this c part, you can simplify it because the c goes to the e. And because e to the negative 1/5 t plus c is equal to e to the negative 1/5 t times e to the c. So e to the c is also another constant, so we will just replace that with a. Now we have a equals negative 1/5 t equals 100b, 100 minus b. So now we just use the initial condition set b of 0 equals 20. So b of 0, so t corresponds to 0, so 0 times negative 1/5 of a equals 100 minus 20, since b of 0 is 20. So now this will become 1 because e to the 0 is 1, so a is equal to 80. So we found the constant. So now we just plug this back in. It'd be 180 a, or 80 e negative 1/5 t minus plus 100 equals b. This is just going through this, subtracting to the other side, and then dividing by this negative 1. So this is the equation given by the separation. So for the point system here, you would first have to get this dB dt's integration right here, and then you find the antiderivatives, you find the constant, which is here, and then you use the conditions here, and the last thing you need is that the time is greater than 0, because you can't have negative hours on the thing. So this is all you have to do. Thank you.